Good evening, everyone. My name's Malcolm Hackett and I chair the board of BRI. Welcome to the fourth webinar of our 2024 series, Understanding Our Changing Bushfire Weather. I know from first-hand experience, understand your weather, know your risk. It's a fact. Tonight we have three expert presenters, Mika Peace, Justin Leonard and Kevin Parkin. Our objective is to provide information to help you and explain how you will be affected. Following the presentations, we will have a discussion and question answering session with Mika, Justin and Kevin, and we'll finish at 9 p.m. This series of presentations has been organised by Bushfire Resilience Incorporated, an independent, community-led, not-for-profit. Our mission is to improve community engagement in reducing bushfire risk by providing expert knowledge and promoting it to households in a timely and practical manner. These webinars have been organised on the lands of the Wurundjeri Woiwurrung people. BRI and our presenters acknowledge the traditional custodians of the many lands from which the presenters and you join us tonight, and the Aboriginal and Torres Strait Islander people participating in this event. We pay our respects to their elders past and present and celebrate the diversity of Aboriginal peoples, their ongoing cultures and 65,000-year connection to the lands and waters across Australia. Please note that the webinars and the presenters are providing information, not advice. Our intention is to provide general information about risks to property, people and animals. It's your responsibility to seek advice for your particular situation. This may be a sensitive topic for some people, and suggested services are shown on the screen. Thank you to our sponsors and supporters, the Bendigo Community Bank branches in Nillumbik and Kinglake, the CFA, the Warrandyte Riverside Market, the Nillumbik Shire Council, the City of Manningham, the Warrandyte Bridge over the Yarra, and Davey Pumps. Thank you for registering your interest and for submitting your pre-webinar questions. You are able to ask questions as we proceed using the Q&A function, but please keep your questions short and to the point. These webinars are being recorded and everyone who has subscribed will be sent the link. Our presenters are industry experts. Justin Leonard has dedicated his 27-year research career to the understanding of how bushfire risk to life and infrastructure can be managed. This research combines learnings from bushfire exposure experiments, post-bushfire survey investigations, and computer modelling of bushfire interactions with buildings. Justin has been a very regular BRI presenter since we began 4 years ago. He always provides information that our audience can relate to and apply. Kevin Parkin is a meteorologist with the Bureau of Meteorology. Kevin's expertise is in forecasting and communicating the risk of severe weather and fire weather events. He has been Victoria's Emergency Services embedded meteorologist for the last 14 years. Mika Peace runs high-resolution coupled fire atmosphere simulations using the Access Fire model to understand fire and atmosphere interactions. During extreme fire events, Mika takes an operational role with fire agencies, predicting fire meteorology and likely fire behaviour. Now, Kevin will now provide his presentation. Thanks, Kevin.
Basically, the outline of this presentation is quite short and sweet. It's about understanding your weather district because that underpins the fire danger rating, and we'll touch briefly on what that means. And also, when we're thinking about fire in the landscape, there's obviously some underpinning weather elements that are really crucial to understand, and I'll touch on them. They're pretty self-explanatory, but I'll also include some that you might not fully be appreciative of. And then we'll conclude by looking at some weather information sources. Now, when you're travelling around in the countryside, you'll see fire danger rating signs, and they're not only representative of the fire danger rating for where you are locally, but it's actually a much broader area than you probably think. It's for an entire weather district. So one of the things you do need to do is get onto the Bureau's website, look for the weather districts and see which one you're in, because the fire danger rating relates directly to your weather district. Not only that, you can establish your which weather district you're in, usually by also going to your fire agency, state-based fire agency website. And I know in Victoria, where I'm from, that's the CFA. You can type in your suburb or location and it'll let you know what weather district you are in. You can see on the left, I've got an example for Queensland, New South Wales, in Northern Territory and South Australia, quite large districts, understandably, and they're a lot smaller as you get closer to the higher population centres. Western Australia is massive, large weather districts, but as we get closer to the southwest, you can see on the diagram on the left there are quite a number of weather districts in that area, and so the fire danger rating relates to that weather district. And of course, Victoria and Tasmania. And I want to just spend just a few moments by touching on an example that you can then use for any weather district that you're in. For instance, if we think about the Central District in Victoria, that's where I live, it extends from Aireys Inlet in the Otways to the Macedon Ranges in the north, the Mornington Peninsula down to Wonthaggi, all the way up into the Yarra Valley. That entire district is represented by one fire danger rating, no matter where you travel in that district. North Central is a little bit of an interesting one, obviously, just sort of squeezes in between the Northern Country and the Central. But I just want you to take away this message that when a fire danger rating is determined, it's usually done in a conservative manner by looking at the most fire-prone area in that entire district, wherever that is. Often in the Central District, it is west of Melbourne, where the basalt plains are quite dry. It could be very, very different from how things are faring, obviously, in the Dandenong Ranges. So the risk is definitely changes across the district, but the approach is very conservative, looking for anywhere in the district where there's a risk, an increased risk of fire, and that will determine the rating for the entire district. So let's just quickly look at fire danger ratings. I know you're probably pretty familiar with them. I'm a real supporter of the simplification of the fire danger rating system to 4 categories: moderate, high, extreme, and catastrophic, outside the no category, of course. And it basically gives you a heads up. It's very broad, that we could see how dangerous a fire is based on that category. And of course, this is really important. We don't want to overcomplicate the message to the community. The fire agency is very clear in the sort of actions you need to take based on that rating. And what you need to know is all you need to know is what weather district you're in, and you can access that information on the website, the Bureau's website, your fire agency website, through various media outlets. And the beauty is, unlike perhaps recently, the ratings are the same no matter what jurisdiction you go to across the country. So that's quite comforting. A rating of high as a fire danger is the same whether it's in the Northern Territory or in Western Australia. The question I often get asked is, how is the fire danger rating determined? And the fire agencies across the country basically work with the Bureau of Meteorology in determining what's called the underpinning fire behaviour index value for each weather district. And you can see there the ratings down the bottom and what we call the fire behaviour index values at the top, which normally the community wouldn't be aware of. But these values are really important for the fire agencies to sort of set their resources, their preparedness levels, gives them a bit of an idea of fire behaviour. As you can see there, this information's available on the Bureau's, on the AFAC website, which basically says, you know, this FBI value is it's not a single physical property. It's basically a high-level concept that unites a whole heap of potential fire behaviour characteristics from fire behaviour models, and it's based on a number of vegetation types, and that's where the real lift has been with the introduction of the Australian Fire Danger Rating System. Instead of just based on grass and forests, now it's based on a number of vegetation types that are much more representative of the risk in the landscape. And the sort of thing that you may have read about or heard about, and certainly the fire agencies are across, is the Fire Behaviour Index informs us about fire intensity, flame height, rate of spread, and spotting potential. So what about weather? Well, obviously the Fire Behaviour Index value is not only going to be dependent on the vegetation, but it's also going to be dependent on some weather variables, and some of them you will know quite intimately. Temperature, relative humidity, wind speed, and recent rainfall. They all get fed into determining the Fire Behaviour Index, which then, as you saw, gets turned into a fire danger rating that everyone can understand. Another question that often gets asked in various weather forums is, you know, what sort of numbers should I be paying attention to in the weather forecast? And you may have heard of this 30-30-30 rule. It's universal, whether you're in Spain or in the United States. It's quite common to just put this in your head, and it's a good guide as to whether fire could be fire behaviour could be more extreme or difficult to control. So above 30 degrees temperature, wind speeds above 30 degrees, and relative humidity below 30 degrees. Quite often in Australia, we sort of think relative humidity below 20%. It's when some of the vegetation can get quite crispy because the atmosphere is quite dry. Two aspects of fire weather I need to share with you, and it wouldn't be complete. One relates to obviously the wind, but wind changes in particular. Really important to have a full appreciation that the stronger the winds are, the greater the risk that fires will spread and not be able to be controlled by the fire agencies, even the very large air tankers that come out to our country from the US to help suppress fires. Very strong, and in fact they struggle to even get off the ground if the winds are too strong. But once we've got wind in the landscape, the fire behaviour escalates significantly, and it escalates even more if we have a wind change. Now, in southern Australia, that could be a trough or a cold front. Some of the most devastating fires that have affected southern and southeastern Australia have been associated with wind changes. But that could manifest as a trough or a sea breeze change that occurs along the eastern seaboard that pushes inland and moves across a fire. Any sort of wind change is likely to exacerbate fire behaviour. And there's a nice little graphic here that's available on the Bureau's website that is a good educational tool that shows how fire can move in one direction quite predictable, but as soon as a wind change comes in and affects that fire, the whole flank of a fire can turn into the fire front very rapidly. The second aspect of weather beyond the temperature, the relative humidity and wind is something called pyrocumulonimbus. I know it's a bit of a mouthful. If you can say that, you're doing well. The takeaway message is it's a fire that basically generates its own lightning. I know it's hard to imagine that something so hot and ferocious can actually generate ice crystals in the upper atmosphere, but this is exactly what's going on. Incredibly dangerous if they do develop, and difficult to get a full appreciation of what might be happening at the surface, particularly if you're under the actual pyrocumulonimbus itself. And you can see there's a few things going on in terms of air being sucked into the fire plume, generating its own cloud. There's aspects like downbursts and lightning generating further fire activity. Basically, pyrocumulonimbus creates very erratic fire behaviour that is difficult to understand and make predictions on. And so the takeaway message there is if a fire generates its own thunderstorm, we'll be looking at fire intensity increasing, erratic fire behaviour, reducing the predictability of fires in the landscape and how they move. In terms of where to access weather information for your fire, obviously the Bureau's website's excellent, has some useful tools. The MEDI platform, which a number of the other weather providers use, the same data. Arguably, they might even display it a bit better, such as Windy and Weather Zone. Very useful websites to get detailed information about the weather. And I just wanted to highlight one, the Bureau's beta website. So I'll just show you on the screen now what you will be doing. If you type in beta.bom.gov.au, here we go in real time. This is just being launched after a lot of feedback from people just like you listening to this webinar. We might search for a location, let's say Arthurs Creek, northeast of Melbourne. There it is, that's the one we want. And like a number of the online platforms now, and like the Bureau's weather app, if you don't already have it, it provides hourly information out for several days. If I click show all, not only do you get your temperature, you'll also get your humidity as well. So quite a humid night, not surprisingly, given the weather pattern we're in southeastern Australia at the moment. So very useful tool where you can get nice timeline of weather variables out for the next several days that you might be interested in. And just to finish off, what about mobile apps? Yeah, brilliant. I love them. I was over in Europe recently. I was using a mobile app just to keep a check of the weather. And that's what I'd do if I was in the country. Of course, it does mean you need to be connected to 4G and you are reliant on that network working if there is a bushfire. My advice, just be confident. Know what the weather app is you're using and how to access the information that you need to access, and not be scrambling around in the moment when there's fire in the landscape. This presentation will be available following the webinar, and there's the websites that I've accessed most of the information in this presentation, and there's much, much more there for you to read and absorb.
Thanks, Kevin. But now we're going to go straight to Justin. Do you want to take it away, Justin?
So yeah, I just wanted to follow on from that great presentation from Kevin to really cement the idea about how weather and life loss impact are tied together, and I guess how the changing context of weather that Mika's going to really drill into is influenced by that life loss and risk, and steps we can take in response to warnings issued in these fire danger categories. Now I've taken a bit of artistic license here in that I've revived some of my old data sets that link fatalities and fire weather, and I've used the assumption that the old FFDI, or Forest Fire Danger Index, and its numbers are roughly translatable to the FBI, the Fire Behaviour Indexes in the new AFDRS system. And that's a real strength of the AFDRS system, is that it tried to maintain an equivalence in the numbering. So a 50 is a total fire band, whether it be an FBI or what we used to remember as an FFDI. So we can relate these older loss profiles with the categories of our current simplified fire behaviour index and the rating system that underpins it. And what's interesting is it's quite well calibrated. So for the no rating area, there is in fact no real measurable life and house loss. The orange line here, or brown line, is house loss, our measured house loss over quite a broad period. from 1926 to the 2011. And the blue line is life loss. So we can see from all of the measured life and house loss from 0 to 100%, we can actually see that it's heavily biased towards, in fact, well over 50% of our life and house loss occurs in this category of catastrophic. So that's really, you know, the 6 to 8 events that have driven all of our life and house loss in this catastrophic area has driven the vast majority of loss. Now, the changing climate is pushing the likelihood and frequency of this category up. And the further we get to the end of the century, the more increase will occur. What's also going to occur is an increase in frequency of extreme classified days, and that'll push the middle of this curve up also, both in life and house loss. And high, is relatively benign, but we will get a lot more highs as well. So, think about those categories and the relative escalation that Kevin articulated. Here it is in terms of the resultant life and house loss and how much of a massive contextual increase it is as you march through these figures. If we talk about the seasonality of fires, you're going to hear from Mika shortly about how fire seasons may in fact lengthen. They might start earlier and finish later. And in terms of fatality context, that means we'll get a broader number of months where we need to be concerned about loss, and we'll see a broadening into the Novembers and March in the loss potential as we look at that seasonality. If we look at what it looks like in a daily profile, there's a really interesting profile, and that is that virtually all of our life loss or fatalities actually occur during daylight hours and into the evening and night. So that's the big drive through the day, the wind change in the late afternoon, and then the persistent burnout into the evening. But a conspicuous absence of life loss in the early hours of the morning through to the beginning. And I guess that's because we tend to enjoy a more moderate event. But you'll also hear from Mika shortly about how the nighttime paradigms are shifting in some interesting ways, and we might actually start to see problematic or more instances of problematic fire behavior, and we might start to see fatalities in those early hours of the morning. If we look at individual weather parameters like temperature, Kevin's 30-30-30 rule that he presented earlier actually stacks up really well. So we can actually see that the vast majority of our life loss context really builds once we've passed that 30-degree threshold, and then continues to escalate in a very clear way. And of course, when you hear about these climate change and a warming climate, directly translatable to temperature and the propensity to have hotter days, and that's going to drive our fire weather to be more severe simply because things are hotter. If we kind of look at that in a sort of a 5th percentile to 90th percentile range, we can actually sort of see a really interesting profile where temperature really has to push well past 30 to even get going. But really the median loss of all of our fatalities is around 40, and by 45, that's pretty much the hotter end of our typical days. 95% of all of our losses is sorted by 45, but there's 5% more loss beyond the temperature of 45, just as a qualifier. So we can expect, warmer days. This temperature profile will play out, meaning that we will risk potentially experience more loss. If we look at wind, Wind is a really interesting one in that we kind of get mixed messages about wind and wind intensity, but by and large, we can expect to get more energy in this climate system, and that means more energy to drive not only average winds, but gusting winds. And I guess the 30-30-30 rule is looking pretty interesting in that we sort of step up in this 20 to 30 range. But I guess there is a bit of a caveat around this particular graph in that this is the 3 p.m. average wind speed on the day that the fatality happened. And what would have almost certainly also been at play is the gusts and the winds at the time of the actual fatality were probably a bit higher than the 3 p.m. average. So that would push that well into the 30 to 40 and beyond category, and why you see a bit of variance there. So that really holds up as a viable metric as well. And in terms of relative humidity, we obviously get the reverse effect. So the lower the humidity, the greater propensity for fatalities and the fire behavior and fatalities. And the 30 rule, once again, works pretty well in that we really get escalating fatality once we see the 20 to 30 range. It starts stepping up and then really gets away in the 10 to 20 and the 0 to 10% relative humidity. Now, interestingly, in our changing climate, particularly down here in Victoria, you'll notice our last few summers have actually been conspicuously humid and a little bit tropical. And the good news is that the climate signals are actually showing that we'll potentially get a little bit more relative humidity on it during our summer periods. And that'll have a slight moderating effect on our fire weather severity. But unfortunately, that's counteracted by the hotter conditions and the potentially a little bit windier conditions. So not all the metrics are heading in the bad direction, and it's interesting to watch how these ones will play off. And I guess when we combine those together, as Kevin highlighted, it's the combination of wind, humidity, temperature, and whatnot drives it. We can also look at this in terms of the context of how that FFDI or that FBI, which are roughly equivalent, can show us our escalation. So our no rating, pretty much no loss, moderate starts to pick up, and then we really see this pick up. Now, these two categories from 50 out to 100 is actually one big fat combined category that we call extreme now. So you can add those two columns together for parity and you'd be up around here. But still the vast majority of our fatalities are in the catastrophic region. And I guess if we want to put one more slider twist on that range of categories, instead of going for the aggregate bars of all fatalities, let's just slice that up into the nature of the fatality, from everything from inside structures in red to which shows quite a nice building trend from moderate through high through extreme to catastrophic. Interestingly, a really big sharp escalation towards the end. Inside vehicles, a lot flatter profile, but nonetheless building as we move through the categories. Open air, conspicuously some losses in no rating, and quite a lot of loss down at moderate. So that's reflective of getting caught in relatively low intensity fires, but caught out in the open with no protection. And that builds, but then conspicuously falls away as we get to catastrophic. And that's because the conditions in catastrophic are actually really difficult to actually even persist outside from a heat stress perspective. And people are intuitively finding shelter in vehicles and homes being the resultant place where the fatality is more likely then to occur. So think about those categories and think about those changing contexts, and really deeply consider the fact that our propensity to have more extreme days and more catastrophic days in our future fire seasons, and how that context will really emphasize those types of losses and risk to your lives and your property. And I'll leave it there. Thank you.
Thanks, Justin. So now we'll hear from Mika with some information that I think will all be very new to us. Thanks, Mika.
Thank you. Good evening, everyone. All right, so I'm going to talk about something a little bit different to Justin and Kevin. I'm really going to talk about the processes and the meteorological drivers of fire behaviour and what we know and what might change into the future. All right, so some of you may have seen some of the detail of the IPCC projections from last year in particular. We're looking at longer fire seasons extending into summer and spring, extending from summer into spring and autumn, as Justin mentioned, and an increase in the number of dangerous fire weather days for a lot of the world, including Australia. The frequency of extreme fire weather days has increased in recent years, and the fire season has become longer in the last 50 years or more in a lot of locations. So overall, we're expecting to see the intensity, frequency and duration of fire weather events increasing across Australia. But we're really interested in some of the detail of that and what it might really look like. So what I'm going to talk about tonight is really an overview or a summary of a paper that was published earlier this year by myself and Lockie McCourt, who's in Western Australia, who some of you may know. And what we were really looking at is what are the processes driving fire behaviour that are outside of what's captured in the IPCC reports. And when you look at all of the references and on all of the studies that are in there, most of them use either FFDI or FWA, so the Canadian Fire Weather Index, looking at climate projections into the future and taking either the midday or the 3 p.m. values, so the hottest period in the day. And what we're really asking is, does looking at the temperature, the wind speed, the relative humidity and the dryness at 3 o'clock in the afternoon or at midday really capture some of the complex processes into the future? So we're really going to talk about tonight some of the things that might not be captured in those projections. So some of the things that we're worried about into the future are overnight fire activity and how much we might see more increasing in fire activity overnight, and we're seeing that already around the world. Some of the other processes are heat waves and droughts and how that changes fuel availability across the landscape. Some of the dynamical meteorological processes, including deep boundary layers that we'll talk about a little bit more, low-level jets, the winds above the surface, and as Kevin already mentioned, pyrocumulonimbus clouds. And I'm going to show a couple of cases from the Badger Fire, the Yanchep Fire and the Corryong Fire, and some people may have had personal experiences in the Corryong Fire. And then I'm going to finish up by talking about some of the implications for future fire regimes and the things we need to think about. So many of you will already know that most fires aren't put out by water bombers. And as we know, the normal diurnal cycle of fire activity, and this is really Fire Behaviour 101, is that fires lie down overnight and will often self-extinguish. And the overnight reduction in fire activity means that the fire crews can put in suppression and containment activities. And that's especially the case for forest fires where you've got continuous fuels over large areas. And as I mentioned, we're already seeing in the satellite data an increase across the globe in overnight fire activity, and that's pretty well documented. A lot of that work's been done out of the United States. So one of the concerns is what's overnight fire behaviour going to look like in the future? Another thing is heat waves, and as we just heard from Kevin and from Justin, the hot days are really the bad ones in terms of fire activity. And heat waves aren't just the daytime hot temperatures, it's also the nighttime temperatures. And a lot of the stress, human physiological stress, is from the nighttime temperatures and the fact that our bodies can't recover overnight, but also fires will continue to burn day and night in a heat wave. When we're talking about heat waves, the high pressure systems that drive heat waves can be a few thousand kilometres across. So we're talking about big systems. They become near stationary for several days. So heat waves don't just affect small pockets or isolated areas. They can affect really extensive areas for several days. And as we know, during heat waves, the conditions tend to get hot earlier in the day and they continue hot into the evening. So what that means is that you don't get an afternoon peak in your fire danger and your fire activity, but your fires can stand up and run much earlier in the day, and they've got a much longer window of hours that are favourable for fire spread. So you've got a much longer number of hours where you're going to get fire spread in a heat wave, and that continue into the overnight fire activity. In heat waves, we obviously do see a little bit of cooling in the overnight period, but that's always a very shallow nocturnal layer. So that shallow cool layer is really near the surface, in the bottom of a couple of 100 metres usually. And above that, you've got a reservoir of hot, dry air that often goes up to 4 or 5 kilometres deep. So all that hot, dry air is always above us during a heat wave. We've just got this shallow layer near the surface. And as we'll see, a fire plume in heavy fuels can actually tap into that hot, dry air above the surface and mix it down to the surface and continue to drive overnight fire activity. And as we've heard, one of the big hazards, particularly in southeastern Australia, and it's really something that happens here rather than other places in the world, we often get frontal wind changes or sea breeze wind changes on the last day of a heat wave. So once you've actually got fire established in the landscape where it might have been burning for several days, you then get the wind change, which changes the open flank of the fire and can then increase your fire spread in a new direction. Heat waves, of course, change the fuel availability. So fuel availability obviously determines how much fuel there is in the landscape to burn. And usually in fires, we're talking about the dead fuel that's available to burn. But as we know, during heat waves and extreme conditions, we also see the live fuel burning as well. So heat waves not only dry the dead fuels, but they also stress the vegetation and they make the live fuel more flammable and available to burn. There was a lovely description from a lady who was in the Black Saturday fires, and she said she knew it was going to be a bad day because the eucalyptus trees were silvering. So as we know, our eucalyptus trees have got a high oil content, and when they're heat stressed, they catch the sunlight and they start to reflect it like a mirror. And she knew it was going to be a bad day that day because the eucalyptus trees were silvering. On the hot days and nights during heat waves, it means that the overnight fuel recovery or the fuel moisture recovery doesn't happen. So usually the dry fuels increase in moisture levels in the overnight period when the humidity comes up, and then they dry out during the day. But because conditions are hot and dry during the day and night, you don't get that overnight fuel moisture recovery. So the fuels are dry and available to burn at night as well. And heat waves and also drought, we'll talk about drought in a minute, they also increase the size of the available combustible fuel in the landscape. So normally when you're talking about the fuel that's available to burn in a bushfire, you're talking about the fine fuel, which is the top image that you can see here. And I like to think of it as the stuff that's around about the size of your little finger. But during heat waves and droughts, the heavier fuels, so the stuff that's the size of your torso or bigger, starts to dry out, and that becomes available for combustion and burning in a bushfire as well. And of course, if you've got the heavier fuels burning, they take longer to burn because they're heavier, but it increases significantly the total energy release, and that then interacts with the atmosphere. This is a photo of drought-stressed trees in Western Australia. Now, it's worth pointing out that definitions of drought vary considerably, different time periods, different kinds of drought, agricultural drought and water drought, but drought effectively is a deficiency in rainfall. And what we get during drought and heat waves is a greater availability of live and dead fuel. And of course, the same kinds of weather patterns and climate patterns that are favourable for droughts are also favourable for heat waves. So we tend to see droughts and heat waves in the same seasons. And drought impacts are dissimilar across vegetation types, and particularly in terms of the time period that the drought will affect the vegetation. One of the big questions about drought is forest mortality, particularly when your big trees will die. And it's really difficult from a research point of view to attribute tree mortality, so trees dying, to a drought, because often there's a lag between when the impacts of the drought are greatest and when the trees die. And that's a big uncertainty that they've done some work in Europe in particular, looking at in climate change, is how the big old trees are likely to respond to novel climate conditions. And the reality is that we simply don't know, because it's impossible to do experiments to see how the tree mortality is going to change in future. Drought cycles are really important as well. So that'll have a really big impact on fuel availability, whether you have a dry year or 2 dry years followed by 2 wet years, or whether you have 5 dry years followed by 5 wet years. So the cycle of fuel growing, so vegetation growing and then drying out, changes considerably, and that alters the fuel availability in the landscape if you've got a 1 or 2 year wet dry cycle compared to a 5 or 10 year wet dry cycle. And it's really a little bit unclear in the climate projections how that might play out. And what we also know is that the fire spread models that are developed in Australia, and which are the ones in the rating system that Kevin in particular talked about, is that most of those were done from experimental fires that happened in sort of previous climate regimes. So we really don't know how those might translate into the really dry conditions, the kinds of conditions that we saw in Black Summer and the kinds of conditions that we might see into the future. So one of the things that we've been doing a fair bit of work on is not just looking at what's happening at the surface and the way the surface conditions are affecting fire behaviour, but also what's happening above the surface and how the atmosphere above the surface influences and interacts with the fire plume. So you've all seen these kinds of photographs. This is one from Kangaroo Island in January in 2020. And what you can see here is that the fire plume in particular isn't just at the surface. It's extending through a real depth of the atmosphere, and it's interacting with the atmosphere and the energy in the atmosphere through a really deep layer. So we call this layer the layer that's affected by diurnal heating or daytime heating is the planetary boundary layer. And what we get is this layer which can mix to 4 or 5 kilometres deep in a heat wave, and we see some of the deepest planetary boundary layers in Australia, certainly much deeper than a lot of other places in the world. And this is the layer that the fire plume interacts with. And then, as I said, in the overnight period, we get shallow surface inversion. So you get a cooler layer near the surface, but that hot, dry air is still above the surface. And these deep boundary layers are really favourable for ember transport and for spot fires day and night as well. So when you've got a really deep boundary layer with a nice plume like this, well developed in it, you've also got potential for firebrands being lofted up into the plume and then carried by the stronger winds aloft and deposited further downstream and then igniting new spot fires. And as we'll see again in a minute, these really deep boundary layers can support deep organised plumes and also convection column development. And what we also see is these deep plumes, they've got a really strong updraft associated with them. Some of these updrafts are similar speeds going up to what we see in a thunderstorm. You get really strong inflow at the surface to replace that air that's accelerating upwards. So you can get really strong environmental winds at the surface, which won't be seen in our forecast models and won't be seen in the forecast that you'll see on the websites because the atmospheric models don't actually know that there's a fire there. So the atmospheric models that we run are usually done without the knowledge about any fires that are in the landscape. So the really strong winds associated with the fire won't be predicted in those models. And Kevin also talked about pyrocumulonimbus clouds. Now, pyrocumulonimbus clouds are an extreme form of pyroconvective cloud. So you can see this little photograph down the bottom of a kind of cute little pyroconvective cloud, little pyro-Q cloud that's sitting on the top of a smoke plume, which is a really different beast to the larger photograph, which is a pyrocumulonimbus cloud, where you've got that really deep cloud extending for 10 or 15 kilometres up through the atmosphere. Now, these fire-generated thunderstorms or pyro-CB clouds can cause new ignitions downwind. Certainly they've been measured up to 80 kilometres downwind for new ignitions at the original fire front. And you can get really gusty, turbulent outflow. So you get really variable winds associated with these kinds of systems. We've also seen fire-generated vortices, some with tornado-strength winds, both in the Australian fires in 2020 and then the 2022 fire season in the United States. So you can get vortices or fire whirls, which have got winds for between 300 and 400 kilometres an hour. So really destructive winds that are generated by the really sort of strong updrafts and then the shear at the surface producing these vortices. And of course, these mean really hazardous conditions for firefighters. So this is a video that was taken in the Green Valley fire. And what you can see here is a rotating convection column. So this fire took a significant run in the afternoon period when the winds were stronger. And then as the winds dropped off in the late afternoon, the whole column stood upright and started rotating. So what we're looking at here is what we call fire and atmosphere interactions. They happen a lot in where you've got complex topography, and you can get wind regimes and updrafts which are really different to the background environment. We've seen these in photographs, and as I mentioned, we don't get these kinds of systems or these phenomena resolved in our weather models, but we have got them in some of the research models that we use. So we use coupled fire atmosphere models to actually resolve these processes in the modelling framework and try and understand the kinds of conditions they form in and the kinds of ingredients that you start to see. We see really deep unstable boundary layers are favourable for these organised convection columns, and of course you've got the potential for rotation in there, and these kinds of rotating convection columns are often associated with fire-generated vortices and really hazardous conditions at the surface. We can also see elevated wind maxima or low-level jets that can drive overnight fire spread, especially during heat waves, and I'll show an example of those in a minute. Whoops. So the first example that I wanted to talk about was the Badger Forest Fire, which was in New South Wales. It was ignited by a lightning strike in late December, and it did an overnight run of 36 kilometres in 6 hours, leading into New Year's Eve. It impacted the towns of Wandella, Cambago and Quama, and the extreme fire behaviour associated with this fire resulted in 2 fatalities. There was a fire-generated vortex. The wind strength is unconfirmed, but it certainly looks like they were tornado-strength winds. That occurred in the Wandella Valley. And the satellite imagery in the overnight period recorded a fire-generated thunderstorm, and that was one of the first times that a fire-generated thunderstorm or a pyrocumulonimbus cloud had been observed overnight. This image from RFS was taken at nearly midnight, so you can see the really active fire behaviour in the overnight period. And at one of the automatic weather stations, catastrophic FFDI was recorded between 4 and 5 o'clock in the morning. So really extreme conditions in the overnight period. And that was associated with winds above the surface that were mixing down to the surface. And this fire was burning in really heavy fuels. RFS estimates were between 20 and 30 tonnes per hectare in terms of the fuel loads, and they may have been higher. The second case was the Yanchep fire. Now, this was in Western Australia. This is just north of Perth. Perth's about 50 kilometres to the south, and this was in December in 2019. There'd been drought in the lead up, so the fuels were really dry, but it's on the coastal plain north of Perth, so relatively low fuel loads compared to what we saw in the previous fire. There was a heat wave. Perth had 3 days over 40 degrees. And the interesting thing about this fire was that the fire effectively zigzagged up the coast for 3 days. So what happened was they had easterly winds from the land, obviously in Perth, all the deserts to the east for them. So really hot, dry winds during the overnight period and in the morning and in the late afternoon. And then the sea breeze came in from the southwest, as it does in that corner of the world, with a real kick and turned the direction that the fire spread. So you can see the yellow arrow there, and this is the Sentinel high-resolution Copernicus imagery. You can see that the ignition point was where the yellow arrow is pointing, and the fire initially took a run up to the northwest. And then as the sea breeze came in, it pushed it inland. Then when the sea breeze died off, it pushed it towards the coast, and that continued for 3 days. On the 13th of December, there was an Ember attack at about 4 o'clock in the morning, and they had to evacuate or put out evacuation calls for the town of Two Rocks in the middle of the night. And the dry winds from inland really limited the moisture recovery. So they had a lot of nocturnal fire spread, made it really difficult to get any kind of containment in the overnight period. But because this was only 50 kilometres north of Perth, they had a lot of resources on it. There were a lot of trucks, a lot of personnel and aircraft on this. And as I mentioned, not particularly heavy fuel loads compared to some of the fires that we've seen in the eastern states and also further southwest in Western Australia. So an unusually difficult fire to fight that ran for 4 days in relatively accessible landscape because there's quite a few roads around there, and they had a lot of firefighting resources in, but it was that changing wind direction with the sea breeze offshore flow that really made it difficult to fight. And the last case is the Corryong fire. So some of you may know this one. This started off as the Green Valley Fire in New South Wales. And what we're looking at here, this is a cross-section of the winds using the coupled fire atmosphere model that we use, Access Fire. So if you look at the plot in the bottom right corner, the red area is the fire perimeter. Sorry, the red outline is the fire perimeter. And that black line is the position of the cross-section that we're looking at in the main image. And you can see that on the y-axis there, we're looking at the atmosphere from the surface up to a height of 9 kilometres, and the black is the shading is the topography, and the red is the wind. So we're looking at a cross section of the wind speed at 10-minute time intervals all the way through the night period. And the yellow and pink bits are showing where the fire line is on the topography. And what you can see here is that there's incredibly strong winds up around 70 to 80 kilometres an hour, around about 1 kilometre or 2 kilometres, 1,000 to 2,000 metres above the surface. And what you can see is where the fire front is, those winds are coming closer to the surface and then accelerating up in front of the fire in the fire plume. So this is one of the few pieces of evidence we've got about how the winds above the surface can interact with a fire plume. And what we can do with this model is run it with the fire on and off. So for the image on, or the plot on the left there, the fire atmosphere coupling is off. So the atmosphere doesn't know that there's a fire there. And you can see there's much lighter winds less than 10 kilometres an hour near the surface in the overnight period, because we've got that nocturnal inversion forming. And as usual, we'd expect to see lighter winds near the surface overnight. In the one on the right, with the fire coupling on and the fire plume is interacting with the atmosphere above it, you can see that the fire plume brings those 70 to 80 kilometre an hour winds down to the surface, and that's what's driving the really fast fire behaviour and produce that really fast fire activity and the really fast fire spread overnight. So it's those interactions between the fire plume and the winds above the surface, not the winds at the surface, that are driving the overnight fire behaviour. So what are we worried about in future? Longer multi-day heat waves supporting overnight fire behaviour and reducing the suppression effectiveness, so making it harder to put fires out at night. Hotter temperatures overall and hotter and longer heat waves producing drier fuels, and then we'll see increased fuel availability, both the live fuel and the dead fuel available to burn in the landscape. There's a lot of uncertainty in drought cycles in the future. Are we going to see 1 to 2 year cycles from wet to dry, or are we going to see 5 to 10 year cycles from wet to dry? And that produces a lot of uncertainty in vegetation regimes in the future, and also how much fuel will be available. We are expecting in hotter temperatures to see more deep boundary layers, and that will support organised fire plumes and an increased potential for spot fires. And with that, there's a potential for really deep pyrocumulus cloud and also pyrocumulonimbus cloud, and those fire generated vortices with fire modified extreme winds. And the plumes the plumes above high intensity fires can bring those winds that are above the surface, the low level jets, down to help accelerate the surface fire spread. And as we see in this this MODIS image on the right here, we've got multiple fires burning in the landscape, and all of these conditions tend to happen not just in isolated pockets, but across large areas, because that's the way the weather system works. So we can start to see multiple fire ignitions in the landscape and really long fire perimeters that have the potential to impact large areas. So what are the implications? With overnight fire activity and multi-day events, you've got a lot of strategic and tactical challenges for the fire management agencies. We'll need more resources for overnight work and staggered resources for multi-day versus single-day events. Do you put all of your resources on the first day, or do you need to manage your resources to extend over weeks or even months of firefighting? As we know, you get a lot more fatigue in hot temperatures and a lot of heat stress. So it's people's physiological response. And also if people are sleeping out in tents or on dongas, you're going to have reduced sleep quality on hot nights. So the human recovery won't be as good. There's also a lot of risks associated with nighttime evacuations, both in terms of getting messages to people and also a number of cases where people have tried to evacuate large animals, particularly horses and cows, overnight. And we will need more training to look at the conditions that are conducive for those overnight fire behaviour, that active fire behaviour overnight, because a lot of our current models assume that the winds and the temperature will drop off overnight. One of the other things is that we're starting to see extreme fires move into areas that are not historically fire prone. So the fires in Hawaii are an example of that, where they've seen fires in areas where they don't necessarily have firefighting resources ready, and they don't necessarily have a well-organised volunteer cohort because they haven't had fires in those kinds of areas in the past. And that's also the case in Queensland in the 2018 and the 2019 fires, where we saw areas of rainforest burn. And of course, they don't have the same organisation of the volunteer response that they do in some of the fire-prone areas further south in Australia. And we will need to look at what the messaging is needed to minimise fire ignitions and also to alert communities to the changing fire environment. So thank you, and happy to take any questions.
Thanks, Mika. That was both fascinating and a little frightening. We're going to, while we get ourselves organised for the panel, just a promo for BRI. We'd ask that you share with others and let them know about BRI. Please encourage your friends and community groups and your family who are living with bushfire risk to register to become a BRI subscriber. If you're a Facebook user, please follow our Facebook page and share our posts. And we thank those numerous groups and individuals around Australia who've been doing that already before this webinar. I've told you before that we rely on volunteer time and grants and donations. And as BRI has grown in popularity, members of the community have asked us how they could make a contribution. And in response, we've now enabled our website to accept online donations. You can just go to the home page and you will see a green Make a Donation button. And I'm pleased to say that people have started using that even before we announced it. If you live in Victoria, have a look on our website and buy some tickets to win a Davey single impeller firefighting pump in our raffle. We do a lot of surveys and they're really important to us. Your confidential feedback enables us to provide the sort of webinars that you want, and your comments are shared on the website and they will help other people. Another big thank you to our sponsors and supporters, the Bendigo Bank Community Bank branches in Nillumbik and in Kinglake, the CFA, the Warrandyte Riverside Market, the City of Manningham, the Yarra River in Warrandyte, Nillumbik Shire Council. Now, this map is the risk shared by most of the BRI team, and the source is the late Kevin Tolhurst's BRI presentation in 2020. And we're in that central area in Victoria, and you can see that most of our shire has significant risk. And lastly, Davey pumps. That's the pump that you can win in our raffle. We're really grateful to Davey for providing this to enable us to raise some funds. So now we're going to go to our Q&A. In this session, we'll try and answer as many of your questions as possible. This might be a question for you, Kevin. When will the FDR and FFDR be made relevant by postcode rather than blanketing a whole district?
Probably a question better directed to your state-based fire or territory-based fire agency. It may happen in the fullness of time. I know in the United States, the areas of fire danger ratings are in much smaller zones. I wouldn't quite say municipality-based, but it may be that in the fullness of time that happens, as long as people can, I guess, juggle their understanding going from one municipality to the number. They might be going from moderate to extreme to catastrophic back to moderate again, if we do have them over smaller zones.
Justin, I think this is a question for you. Can you give your opinion on how fire dangers lower than catastrophic can pose a risk to life and safety, please?
Yeah, well, certainly around 40% of our life and house losses actually occurred below catastrophic. The typical numbers of lives lost per event sort of drop below, well below 100 per event. But there's plenty of problematic fire behaviour that will present a risk to anyone caught in a car. House loss occurs quite frequently. It's just a lower category of severity with a few less unknowns compared to catastrophic, where the extra wind context really starts disrupting houses and making things problematic. And yeah, you just get a slightly more moderate version, but plenty of life risk to consider. And you know, many vulnerable people should consider that as a trigger to not be in a bushfire prone area if they can help it.
I think this one's for you, Mika. Ignoring recent major wind events, and we've had a few in Victoria, has climate change affected the weather by there being more windy days?
It's a good question, and there's not a strong signal for wind in the climate outlooks. It's one of the things that they have looked at. So there's stronger signals in some of the other meteorological elements, including particularly temperature, obviously, but also dew point. But the wind signal is actually quite mixed. And I'm kind of curious about that, because when you look at the wind signal, it's usually associated with stronger winds, usually associated with low pressure systems. And there's a lot of questions about how well the climate models are actually resolving the processes in the upper atmosphere. So the upper atmosphere, of course, drives the development of the surface system. So if we've got stronger winds at the surface, we'd expect them to be associated with stronger low pressure systems. And we're really not quite sure how well the climate models are driving that upper system that then the surface system becomes a reflection of. So much stronger. Sorry, long answer to the question. Much stronger response in elements like temperature and also rainfall, but there is that uncertainty in how wind's going to play out in future climate regimes.
I think a question for you, Justin. What data is available online to assess current fuel loads around my house for a 5-kilometre radius?
Nothing available in a public sense at the moment, but certainly plenty of work to create those consistent data sets that will probably be updated around every 2 to 3 months, and aspects of those will make it into the public domain. But I'd say within a year, you could expect to find sources like that to further understand your local context.
And is that work that the CSIRO was doing, or is it a multi-agency?
Yeah, we're building national versions of that, and the states are reviewing the adequacy of that, and they'll adopt that according to whether they feel comfortable that it's relevant for their state and the various regions in their state.
Kevin, this might be one for you. How can we get more information about weather, hazards and climate change into schools?
Some very good resources actually on the Bureau's website, and some of them I put at the end of my presentation. So if you didn't capture that, make sure you get the slides afterwards. I'm obviously only aware of what the Bureau makes available via its online platform. There are some educational resources, including climate change resources as well, that you might be able to avail yourself of. So a little bit of probably searching on the Bureau's website will probably reveal a treasure trove of information that will probably answer your question.
If I'm reading this correctly, what influences this? I think this is one for you, Mika. What influences the strength and direction of northerly wind in Victoria from a northwesterly or northeasterly or direct northerly?
It's usually the position and the strength of the high pressure system. So when we get northerly winds over Victoria, it's usually associated with a high pressure system in the Tasman Sea, and the wind is going anti-clockwise around that system, so it's coming down off the continent. So it really depends on the size of the high, the location of the high, and also the mobility of the high, so where the high is moving. So on a frontal change day, for example, we'll start to see the winds starting off maybe from the northeasterly, and then as the high moves out and the next system comes in, the winds turn more to the northwest, They tend to get hotter and drier, obviously, the more they've got a land trajectory. All of the hot, dry reservoirs are usually over the centre of the continent. But it really comes down to the position and the location of that high pressure system. And there's a lot of nuance in that as well. So high pressure systems can be quite different, but also whether or not you've got an approaching change as well.
Thanks. Kevin, what will be the latest time of day for an FDR to be changed for the following day?
So an FDR to be changed for the following
For
day.
the following
Well, I've known the fire danger rating to sometimes change in the morning of the current day. So what typically happens is the algorithms that determine that fire behaviour index value that I talked about that underpins the fire danger rating, they get calculated at the Bureau of Meteorology with input from the fire agencies about fuel. And that's usually made available by 4 o'clock in the afternoon to determine those ratings that appear suddenly on your fire agency website and also the Bureau's website. And then overnight, there's further work done by meteorologists that are observing the weather and the latest model guidance, and the numbers crunched again and the ratings come out for the current day, usually by around 6:30 in the morning. Now, often they don't change, probably 95% of the time they don't change for your district, but occasionally when the weather is really dynamic, maybe the front is moving a lot faster, maybe a lot slower, maybe there's more cloud coming in overnight, can all impact the fire danger rating, and that'll be evident at 6:30 in the morning. So that's usually the last time that the rating will be locked in, 6:30 in the morning, if there has been any change compared to what was issued the previous evening. Hopefully I've got all my days and evenings and mornings sorted there and you've made sense of that.
I'm going to get you to follow up with something else, I think, but Mika might want to say something too. How accurate is the new, and you might need to explain the acronyms, is the new FDR system and FBIs compared to the old ones? And are there other things like TFBs that should be taken into account when setting triggers?
Look, very simply, it's out of my sort of realm of expertise. Beacon might be able to add more, but I know the CFA who I work with, they've got people, they've got scientists, technicians that are looking at the relationship between the old FFDI system and the current AFDRS and trying to interpret it better and what it means for fire risk and fire danger ratings. So that's an ongoing project. The science is there and it supports the move to this new system. So it's about bedding it down and understanding it, not only internally for the agencies, the fire agencies, but also for the community when you see that fire danger rating outside and online. And then the next part of that question was, what was it related to again?
Are there other things? Are there other things like TFBs? What's a TFB?
Total fire ban.
Oh,
and
sorry.
I don't think it was anyone's presentation. And of course, that's the responsibility that's issued by the fire agency in your jurisdiction, based on the fire behaviour indexed information that the Bureau provides the agency. So that's poured over. And often it's related to extreme fire danger, not always. Sometimes TFBs, as it was a couple of weeks ago in Victoria, was issued when the fire danger was only high. And that's due to the fact that there was already fire in the landscape. So there's a number of decisions that the fire agencies lean on to issue a TFB. And it's not solely fire danger rated, but often is linked to extreme or catastrophic fire danger.
Now, these are probably questions that really should be put to a CFA person. Justin, you might, and we could do that at some stage, but you might be able to shed some light on it. Why is there no fuel reduction program where forest borders and penetrates communities?
I don't have a scientific answer for that one, sorry.
Okay.
And not aware where that doesn't happen either.
we'll get it. We'll speak with some CFA people in particular. There's another question related, which I don't expect either of you to answer. It says climate is changing rapidly. Is the CFA able to handle this change, as nothing is going to be the same as it was, given that fire behaviour will be unpredictable? And I think that's what you've been demonstrating to us, that this is the challenge for them. And I'm imagining, but we'll get an answer, that has to be new strategies.
Can I make a comment there,
Sure.
Malcolm? I think one of the things that's really concerning the fire agencies looking at future climate regimes is resourcing, because obviously the resourcing available in terms of firefighting capability, the number of volunteers on the ground, and also the infrastructure is really limited. So there's going to come a point where they simply don't have the resources to respond in the way that would be optimal to the fires that we're going to see in the landscape. So there's going to be decision points about, how do we optimise the use of resources that we've got? I think on that, it's worth mentioning there was a great piece of research that was done by RFS after the Black Summer fires. And the statistics were something like there were 2,500 homes that were lost in New South Wales, but there were 14,500 homes that were saved. And that was with the volunteer capability of RFS. And we often hear about the homes that are lost, but we much less often hear about the homes that were saved.
This one's definitely one for you, Justin. Do most bushfires start from lightning strikes?
No, I think across Australia, human-caused ignitions cause the most fires that cause loss. There may be a slightly different statistic for fires in general, including the fires that sort of start and are benign and don't lead to loss.
I guess this might be you too. Does humidity above 30% slow the spread of fire or reduce the risk of fire occurring?
I think the right answer is it does both. So a higher fuel moisture level moderates the rate of spread, but also for the same influence, higher moisture content fuel will have a less propensity to ignite and start growing from that ignition.
I think it's you again, Justin, and I've wondered about this myself. Is the correlation between weather and fatality due to people realising too late that the weather has induced fire conditions they had not anticipated and the situation has escalated too quickly for them to act or escape?
Yeah, the vast majority of people that die either in their house or outside, the in the house is kind of, well, it's too late to leave, I'm not gonna make a run for it. That's the by and large the right thing to do, to try and shelter in the house when you've realized that situation is too late to move out into the landscape. The really interesting statistic is that of the people that lose their lives outside, close to 90% of those are within 500 meters of their own home, which really does flag the issue that they may quite likely have attempted a late evacuation when they've realised that things have escalated and fires have begun or become active in their immediate region, and they've fled and escalated their risk or put themselves in harm's way, because moving away from the protection of a house into, say, a car or out in the open is an escalation of your exposure to those severe conditions when they come to pass.
Yeah. Kevin, is there any way we can get better localized data from the bomb? And the example here is my area was hit by a storm cell at 8:30 last night, which dropped 35 mil in 30 minutes. According to the bomb, we had 11.6 for the 24 hours. Is there likely to be, or are there places where you can get more localized data?
Oh, look, I would love as much data as possible to look at and analyze. And obviously, every time we put instrumentation in, there's a cost associated with it. We actually rely on a lot of volunteers, just like there might be on this call today, in reporting rainfall reports into the Bureau. And of course, we don't have them everywhere. There's a couple of things I can point you towards. One is a website. The Bureau has its own WOW website. If you search for it on the Bureau's website, it's people with private weather stations that make their information available to the Bureau. It might not necessarily make it into the official Bureau's network of data, but it's available to look at. But there's also another website called Wonderground, and there's thousands of weather enthusiasts, I'll call them, that are happy to share their weather observations with the world. And meteorologists like myself, operational meteorologists like myself, will actually rely on this information in areas where we don't have data, just to sort of see what might be going on, and knowing that it might not, the data might not exactly meet sort of Bureau specifications. The other thing that you can do is on some of our major radars, especially the city radars, there is an option to turn the 21, 2 or 24 hours of radar imagery into a spatial map of rainfall that might give you a better indication than a point value that might be further from where you are and not representative. Sometimes that spatial map from the Bureau's website can be just what you need if you want to more detail around the rain in your area compared to a nearby suburb. Hope that helps.
It does. Thank you. I don't know whether this is for Mika or Kevin. How many catastrophic days should we expect in the Wimmera and Mallee in a future bad fire season?
I'll leave that for you, Mika.
It's I think probably the point that we've tried to make tonight is it's really hard to put a number on it. But it could be a lot more than what we see at the moment. That's certainly the expectation, that things are going to get worse. And they're likely to be longer into the shoulder season as well. So we're probably more likely to see those really bad days in spring and in autumn, and not just in the traditional summer months. I think probably one of the concerns is that you might see more back-to-back days as well that are really bad, because we'll see increased frequency of heat waves is one of the main drivers there. So it might not just be a single day event, but a multiple day event where you've actually got fire perimeters expanding day and night. And that was one of the big problems I've had in the Canadian fires and the Northwest American fires in recent seasons, is that they've just seen these fire perimeters continually expanding day after night, which obviously has really different implications in terms of resourcing. So hard to put a number on the exact number of days, but certainly longer seasons with more concern about multi-day events inside those.
I think this one's for both Mika and Kevin. Mika mentioned that pyro cumulonimbus clouds are hazardous for firefighters. What should a firefighter watch out for on the fire ground to see if such a cloud is forming? And where would be the best direction to head to protect themselves and their crew?
I've got a couple of examples I can provide. The Grampians Mount Lubra fires back in 2014. The terrain obviously has a big influence on the fire spread, intensity, direction. And on one of the days, the upper atmosphere, as Mika explained in her presentation, interacted with the fire at ground level, generating its own pyrocumulonimbus. And before that occurred, the fire behaviour analysts working with the operational meteorologists were able to identify that risk, and it was communicated through the Incident Control Centre. So what they set up was air observers and people at a distance from the fire to monitor, every 5-10 minutes what was going on with the smoke column, and would it, and let the Incident Control Centre know if and when pyrocumulus was starting to develop. and if it was exploding upwards. And that's what happened. And when that did occur, and there's been many instances like this and fires across the landscape since, they just take the firefighters typically off the fire ground until fire behaviour becomes much more predictable and safe to sort of re-engage. But you're right in that there are risks associated with people and crews on the fire ground, because if you're in the smoke and you don't know what's going on upstairs, you're relying on that intelligence coming to you from the incident control centre, because you have no idea that there might be a massive pyrocumulonimbus brewing, as Mika said, can thrust up into the atmosphere 10, 12 or more kilometres very rapidly. And as someone explained to me once, it was it's like holding a massive vacuum cleaner at the top part of the atmosphere right above your fire in terms of the amount of vertical motion that's going on. And just to give you an idea of the strength of that vertical motion, this is going back to 1985. There was a fire called the Avoca fire, and I was fortunate enough about a decade ago to speak to an air observer who had to go in under or into the near where the fire was, in and around the smoke. They were looking for some crews, and he said all of a sudden the plane got sucked up into the fire. And what they didn't realise at the time was that there was this massive pyrocumulonimbus developing with a very strong vertical acceleration. And some of the research suggests maybe as much as sort of 200 kilometres an hour in events like this. Fortunately, they got spat out of the pyrocumulonimbus, and meant that the aircraft went turtle, and about I believe they said a couple of thousand feet above the ground they were able to sort of upright themselves and fly to safety. But they didn't know what was going on upstairs. But this is they're very aware of this now in the incident control centres, and they set up plans in advance to make sure this sort of messaging is communicated. And because of the erratic fire behaviour that can occur during these events, the strategy in most instances is to take people off the fire ground. So if they're taking fire agency staff off the fire ground, you can imagine you don't want members of the community in and around these sorts of beasts.
I'm going to do something we've never done before and go 5 minutes over, because we had a problem with our start. I want each of you to give me one call to action for we've received all this information tonight. If there was one thing you wanted people to take away and act on or build into their fire plan, what would it be? Justin?
I would say the messaging around how our weather context is changing under a changing climate will be a constantly evolving process as better models and better analysis of those models come out. And in the meantime, and while that knowledge is developing, trust the knowledge that we already have and the recent history and distant history that define fires and the likelihood that they occur in the process. Don't throw out, or don't become sort of helpless in your thinking that it's all changed. We have to sort of progress from that history to how it evolves, but it'll happen incrementally and progressively. So keep your ears open.
Thanks, Justin. Mika?
Yeah, probably echoing Justin's comment, but also going back to the previous question about PyroCB. There's a massive multi-million-dollar field campaign that NASA is being set up with NASA funding in the United States. So it's probably the biggest ever field campaign looking at fires over the next 2 fire seasons. And we've been talking to some of the people who are involved in it. But there's a huge amount of research that's going on in understanding these processes and then being able to predict them better. And we're also constantly developing new and better ways to use the satellite imagery in real time to monitor fires and also to predict them. So a lot of what we've sort of talked about today was about ratings and also understanding what happens after a fire. But we're getting much, much better, and the science is really evolving about real-time fire activity and what's happening in real time. We're getting better tools to monitor that and understand that through things like satellite data and predictive tools. So when a fire is in your area, make sure that you're tapping into the information that's available through the fire agencies. ABC radio is a great source of information, and we'll often be updating them in real time. So really just use the information sources that you've got in real time to stay informed and be aware of how the situation's changing, because fires move fast and they can change really quickly.
Thanks, Mika. And Kevin, finally with you, what would be the big takeaway, do you reckon, that hasn't been mentioned?
Just leveraging off just what Justin and Mika just at the end there, just around situational awareness. Just know what's going on. And, you know, we think we've seen fire, and, you know, most fire moves predictably in the landscape, put out by fire agencies, but it's those events that are rare. And Mika touched on some of the extreme fire behaviour that can occur, that can often catch us out. So if you're just aware situationally, you know, what is a northerly wind or an easterly wind? What does that mean for you? What is the forecast temperature, and what's the actual conditions, you know, the closest weather station to you on those extreme days? And you know, I think it's almost mandatory now that, you know, everyone has the emergency service app, whatever jurisdiction you're from. So you get this latest intel of where the fires are in the landscape, and you've already got a good conceptual model of the weather of the day. So yeah, that'd be the take-home message. It's all about situation awareness.
Thank you. Thank you all. That was a fantastic session. We really appreciate your contributions once again to the webinar. Following tonight's webinar, you'll receive a short confidential feedback survey. Please take a few minutes to respond. We use that information to prepare for future webinars. I'd like to acknowledge Max Garner, Mark Gravel, John Huff, Lisa O'Brien, Peter Mildenhall, Max Coleman, Jason McFadden, Linda Snell, and Rob Reed-Smith for their commitment in conducting and promoting this webinar series and maintaining a very informative website. Thank you also to Glenn Albiston, Arthur Coates, and Maggie Broom for their assistance. A special thank you to Rowan Thornton of CFA District 14, our Zoom host, who again did a great job for us. It's been a pleasure for BRI to provide the 2024 webinar series. We've learned a lot, and we hope you have as well. BRI will keep you informed about website content as it's developed. Please look on our website, have a look at the Davey Fire Pump raffle, and consider making a donation. Thank you all, and good night.